Good day, viewers. Welcome to this class, and today we will be doing a topic we call measurement and its units. Measurement and its unit. What is measurement? Measurement is the process of determining the size, the amount, or the degree of something by comparing it with a standard unit. It is just what? Talking about the size, the amount. So for measurements to be precise and for it to be very correct, there has to be a comparison. You have to compare it with something. So you are comparing it with something else that has what? A standard unit. So measurement is what? It is essential in science, and it is what? Very, very important in our day-to-day life. For example, if you are driving a car, there has to be a measure of the speed of the car. If you are using your electricity, there has to be a measure of the quantity of electricity that you are using. If you are walking a particular distance, there has to be a measure of the amount of distance that you have covered over a period of time. In fact, time itself has to be what? A measure. It is what? Measured in comparison to something of what? A standard unit. What do I mean? When you wake up in the morning, without a measurement, there is no way you would have known that, oh, I woke up by 8 a.m. or I woke up by 5 a.m. So measurement is very, very important in our day-to-day life. In fact, even when we cook our food, what we are doing is measurement. You don't expect to be cooking a cup of rice and then you pour the whole Dangote soda that you have in your house into it. No. Why? Because there's a measurement. There is a required amount, a precise size that is what required for it. So moving on. So we have certain units that we call the standard international unit. The standard international unit. So the international system of units is what we call the standard international unit. Now these standard international units are based on certain quantities. There are 7 quantities, but in some textbooks you see that there are what? 8. But according to the SI unit, this international system of units, we only have 7. The last one which was added, which was magnetic flux, was later added after the standard international unit already came up with the 7. And that's 7. The 8th one, which was what? Magnetic flux, was what? Added, and it can also be called a derived unit according to the what? The standard international unit formula. So what are the standard international quantities and their units? So the quantities that we have, so we have the quantities and we have their units. So these quantities that we have according to the standard international system, the first one there is mass. Mass is measured in kilogram. Kg. Then we have length. Length is measured in meters. Then we have time. Time is measured in seconds. Then we have current or electric current. You can call it electric current or you can simply call it current. It is measured in ampere. Then we have temperature. It is measured in Kelvin. Then we have amount of substance. It is measured in mole. Then we have luminous intensity. It is measured in candela. So these here are the 7. These are the 7 that was given by the international system of units. So the international system of units gave these 7 as the what? The generally accepted international SI units that what we know. These SI units are generally accepted, and from this SI unit where all other units gotten from all other quantities are also what gotten from this. So every quantity that you are thinking of in physics is gotten from this what 7 quantities, including not in some textbook you see that they will add the 8th one, which they call magnetic flux. Magnetic flux, and the unit of this one is Weber. But the standard international unit or the international system of units said that what the magnetic flux is not a is not an SI unit, or it is not a fundamental unit, because it can be what derived from what another, the combination of 2 or more other quantities. Moving on from there, we have these quantities which are just listed here already. Now, these quantities are all based on certain principles. For example, your distance is measured in meters, but it is not exactly talking about what length. It's talking about what distance. And distance here is a function of this what of this fundamental quantity we call length. So this fundamental quantity, therefore, we have the same unit as what the distance that we're talking about, because what distance also will have to be measured in meters, as it's talking about what length. So if I'm moving from here down to this place, I've covered a particular length. I can easily measure it what using a ruler or using a tape. So that distance I've covered will also be measured with the same what unit as what length. So distance, which is what between 2 points, is what measured in length. Then the mass of an object is always measured in kilograms. So if I want to measure the bag of rice, the weight of a bag, or the mass of a bag of rice, I measure it in what kilogram. Moving on from there, we have accuracy and precision. Accuracy and precision. These two are not the same, because they are quite different in physics. Looking at this, what is accuracy? Accuracy is talking about how close a measurement is to be true or accepted. So a particular reading or a value can be accurate, but it might not be precise. So it's the level of closeness to the true value of a reading is what makes it what accurate. Then what is precision? How close repeated measurements are to each other. So if I have 2 or more values, how close are they? It's talking about what? Precision. So if I take a pendulum experiment, for example, and I have 2, 3 values, let's say I have 3 measurements for my time, or let's say I have 2 measurements for my time, and these 2 measurements for my time are very widely spread, it means that my measurement is not precise. It may be accurate, but it is not precise. So that is what precision and accuracy. Moving on from there, a thermometer is giving the same reading every time, even if slightly wrong, is precise. Now, what is this saying? That the thermometer reading might not be correct. It might not be accurate, but because it is given the same reading over time, or close reading over time, means that it is what? Precise. So a readings can be precise and still not be accurate, and readings can be accurate and also not be precise. So this diagram is showing here what precision and accuracy is talking about. Looking here, I have values like this. Look at this. It said accurate but not precise. Then here I have precise but not accurate. Then here I have both are accurate and both are precise. Why? Because they are all within the same value, within the same range here. But here they are close here, but they are not at the exact point. We're trying to get the midpoint, but they are not all at the midpoint. They are all at the corner, but they are close by. While this, I have some of them to be at the midpoint, while the others are spacedly apart. Now, although they are spacedly apart and they are all in this place they are accurate because they are within the circle, within this inner chamber of the circle, but then it is not precise. Why? Because they are widely apart. There's no accuracy. The accuracy there is correct, but then they are not what? Precise. They are not close together because I have what? A number of values. Moving on from there, we have measuring instruments. Now we have different measuring instruments for different quantities. The measuring instrument for mass is not the same measuring instrument for length. So these measuring instruments differ, and because they differ, they do not have the same degree of accuracy. For example, if I want to measure length, I have different measuring instruments for measuring length. I have the meter rule, which you also call ruler. In this case, you can use your ruler. But most likely in the lab, we use what we call the meter rule. Now, the meter rule is a rod-like structure with just about 1 meter long. So we have the vernier caliper, we have the micrometer screw gauge. Now, your meter rule can measure values with a particular degree of accuracy. That degree of accuracy differs depending on the apparatus. So if you have seen your meter rule, you will discover that your meter rule has what? Its calibration, such that I have values. If this place is 0, I can have other values here, and then I will have 1. Then continue that way, and then I will have 2. So it is what? Graduated in what? Centimeters. So in that 1 meter, I have what? 100 centimeters. In between each 1 centimeter, I have 10 smaller units in between. So if 1 centimeter and I have what? 10 smaller units, it means that I have what? 1 divided by 10, which will give me what? 0.1 centimeters. It means that this particular meter rule can measure to a degree of accuracy of what? 0.1 centimeters. So using my meter rule, I can easily measure object up to what? 0.1 centimeters. But if I'm using a vernier caliper, my vernier caliper can measure smaller objects than the meter rule, and can even be used to measure objects that have hollow cavity, like the inner diameter of a cylinder, like the thickness of my pen or my marker. I can use what? My vernier caliper to measure it. Also, the vernier caliper also has its own limitations. Why? Because it cannot measure extremely tiny objects. So, for example, if I want to measure the thickness of my hair, if I take a hair strand and I want to measure the thickness, I cannot use my vernier caliper. I have to use what? An apparatus that can measure even smaller lengths, like the micrometer screw gauge. So your vernier caliper can measure up to what? 0.01 millimeter. So 0.1 millimeter, that's what your vernier caliper can measure. But the micrometer screw gauge can measure up to 0.001 millimeters. So all of these are what? Talking about what? The instrument that we use for what? Measuring length. We also have other instruments for measuring mass. If you want to measure mass, you can have what? Instruments such as the beam balance, the chemical balance, your spring balance, your electronic weighing balance. So you have your all of these apparatus for measuring what? Mass. And they all have their degree of accuracy as well. So the degree of accuracy of a device tells you the minimum quantity that particular apparatus can measure. So each one has its own. And we also have what? Apparatus for measuring what? Time. Like your stopwatch is for measuring time. Your stop clock is for measuring time. Your atomic clock is also for measuring time. So all of these are for measuring time. We also have quicksand. There's this quicksand. If you watch all these Greek movies, you realize that when they were measuring time there, they used what? The quicksand, because there was no clock then. So all of these are what? Apparatus that we use for measuring what? Time, and they all have their degree of accuracy. So you cannot use your wristwatch, which is also a device or an apparatus for measuring time. You cannot use your wristwatch in what? In a laboratory experiment. Why? The degree of accuracy differs, because in your wristwatch, it measures time up to about what? 1 second. It does not measure 0.01 seconds. It does not measure 0.1 seconds. So your wristwatch measures what? Time in seconds. But your stopwatch can measure time up to 0.01 seconds. So the degree of accuracy differ for each of these apparatus. Moving on from there, we have other quantities or other apparatus, like the apparatus that we use for measuring what? Temperature, the apparatus we use for measuring current, the apparatus we use for measuring the amount of substance, the apparatus we use for measuring the luminous intensity. All of these are different apparatus. For example, if I want to measure temperature, I have the thermometer. The thermometer is an apparatus for measuring temperature. If I want to measure current, I have the ammeter. So all of these apparatus are used differently and they all have their degree of accuracy. Let's move on from there. Let's talk about error and the analysis of error. So what is error? Error is just talking about what? The imperfection in our reading. So measurements are generally never perfect because errors are unavoidable. So either the error is committed by the human or the error is from the apparatus that is used. Let's say, for example, I'm trying to measure the thickness of a piece of paper. And then I used, let's say I used a vernier caliper. And when I use my vernier caliper, I realized that my answer might be correct, but it is not very, very correct because that piece of paper cannot be measured accurately using a vernier caliper. If I had used a micrometer screw gauge, I would have got a closer reading. Even that closer reading is not 100% correct, but it is more correct compared to that of the vernier caliper. So measurements are not 100% correct. They are not perfect because errors are unavoidable. But the least we can do is to minimize the error. So we minimize the errors, not what? Perfect our readings. Okay, what are the types of error? The first type of error that we have is the systematic error. What are systematic errors? These are errors caused by consistent faults in equipment or method. They are predictable and they are repeatable. So errors that can be predicted and that can be repeated, and these errors are caused by faults in what? In the measuring equipment or the method of measurement, like I just explained earlier. These are called what? Systematic errors. Like if I have a scale that is always 0.5 kg heavier than actual weight, meaning that if I put my weight, any weight of an object on that scale, it will always add 0.5 kg to the actual weight. So if the actual weight was 20 kg, that measuring instrument is going to measure 20.5 kg. It has added its own 0.5 kg. That's what? An error from the apparatus. And because of that error from the apparatus, we'll call it what? A systematic error. Why? Because this error will repeat itself irrespective of the numbers of experiments that I do. This error will keep what? Happening. And it will be what? Consistent. Meaning, it is not going to change from 0.5 to become 0.6. No. Because it is what? A systematic error. Moving on from there, we also have other errors like random error. What are random errors? These errors are unpredictable variations in measurements. They change. They are not predictable. They are not consistent. So you can have errors like these that are constantly fluctuating. So when you take these kind of errors, these errors are usually caused by other factors other than what? Factors that has to do with what? The apparatus itself. They are not non-zero errors. Like if I want to read a meter rule and then I discover that my meter rule does not start from 0, let's say it starts from 1. That is a systematic error. Because each time I'm measuring, I know that my meter is only starting from 1. In all my readings, this not starting from 0 will be consistent. But in random errors, that is not the case. In random error, like I have error due to parallax, for example, as a random error. Why? Because each time I look at that particular reading, I will have a different variation. And their difference, let's say when I did the first one, instead of me reading 20.50, I read 20.60. And then somebody else looking at that same thing, look at it and saw 20.50. And then another person looking at it, we see 20.55. So these errors are not consistent. Somebody might even look at it and see 20.80. Why? Because these errors are what affected by the human factor. And we'll call them what? Random errors. Moving on from there. Now, these errors are as a result of human mistakes. So apart from the random errors might not necessarily be caused by humans. There are other factors like environmental factors that might cause it. So we also have other classifications like human errors, although human errors are also random. So they're also classified as random errors. Moving on from there, we have what are the importance of standard units? Now, the first and most important of all the importance of standard unit is the fact that they are globally accepted. So standard units are the generally accepted units. We call them the fundamental units. They have to do with what? The fundamental quantities. They are the what? They allow global communication of measurements. They ensure that there's what? Repeatability. They ensure acceptability. So these units are generally accepted and they are what? Reliable. So irrespective of the numbers of times that you repeat your experiment, these units will remain the same. So, and they help to facilitate trade, they help to facilitate science and what? Technology, and they will prevent confusion. Ordinarily, if these units are not there, I can just wake up one morning and say, the unit for me measuring length is a shukbufo. That is my own unit. I can decide to call it, let's say the unit for measuring time should be wire. Or let's call it book. Why? Because I decided on my own. But these standard units have been placed there so that there will be what? Accuracy. And there will be what? You will be able to repeat this. And you can transfer that information from generation to generation. Why? Because it will remain the same. Moving on from there. Collectively, measurement and unit are the backbone of science and technology. Without measurements and units, then science and technology will not function properly because we depend on values for our measurement in science. We depend on data. So we continue to collect data, and those data help to inform our decision in science. So if the magnitude of a particular quantity cannot be measured, then that quantity cannot efficiently be experimented on. So we depend on data, hence it is very, very important for us to understand SI units. And we'll be able to find their degree of accuracy and precision. So without precision, accuracy, and measurement, then we have done nothing in science. So that is why this topic is very, very important in science. It is what? The backbone of all our experiments. So let's look at certain questions based on this topic. So we've come to the end of this class. We've done past questions on this topic, measurement and units. We've done questions on it. We've solved certain questions in our channel. Don't forget to go to the channel and check out those questions so that you test your knowledge of what we have done so far on this topic.
Hi, I'm sure you enjoyed the content you just watched. To see more episodes as that, preparing you for your oncoming exams, Smash the subscribe button on this channel right now and visit the playlist that we've made for you, covering over 50 type of different exams, including JAMB, WAEC, Cacao, NET, IELT, and the likes like that.